Good morning, students. I'm Johnson George, physics lecturer. We will today try to understand what is current electricity, which you have already learned in class 10, the first term. So, class 10, current electricity. So I hope you have understood a little bit of current electricity in your class 10. Naturally, you may have forgotten this because of your final exam is 2 and all. Generally, students will forget what you have learned in first term, so that is not good, but we will continue, try to remember what you have learned in class 10, current electricity. So there are some basic terms to understand. If you understand these basic terms, it is very easy to continue your grading of your 12th class mainly. So 12th class, more than 50% of the topic is based on current electricity and electricity. So it is very important for you to keep it in mind, all the important facts about current electricity. So that is why we try to revise once more so that you keep it in mind, all the principles and basics of current electricity. So there are certain terms we are going to discuss today. The first thing is electric current. So what is electric current? So current is nothing but, nothing but flow of charges. It is a certain amount of charges flowing in a conductor in a unit time. So we call as electric current, or in other way we can say that rate at which the electric charges flow in a conductor, or rate of flow of electric charges in a conductor. Means a charge is start flowing from one point to another point in a conductor, and if you connect it with the time rate of flow of electric charges. So it is represented by letter I. So rate of flow of electrons, or electrons are nothing but charges. Electrons are the charges here. So rate of flow of electrons, or the flow of electrons per unit charge. So we can make it in equation form, that is I is representing the electric current. I is equal to Q by T, where Q is the charge and T is the time. So I is equal to Q by T, rate at which the time rate at which the charge is flowing through a conductor is what we call current, electric current. It is measured by this unit. So unit is ampere. So ampere is the unit of current. Okay, 1 ampere of current passing through that. So the current is nothing but rate of flow of electric charges. Here electric charges are nothing but electrons, and it is measured in terms of I is equal to Q by T. Q is the charge, T is the time. So rate at which electric charges flow. How do we measure this value? So we use a device to measure the electric current. The device to measure electric current is, we use is ammeter. So ammeter is a device we use to measure the electric current. So we know what is electric current, the rate of flow of electric charges, and its equation is I is equal to Q by T, rate of charges, and its measuring unit is ampere. So it is an SI system of unit. You are familiar with the SI system of unit. So ampere is the unit of measurement of electric current, and which device we use is ammeter. So ammeter is a device which is used to measure the electric current. Now let us understand what is this electric current. How is it flowing in the conductor? Is it clear, everybody? Now let us move on to understand how the electric current is flowing through a conductor. Suppose this is a conductor for you. It is a wire, an electric conductor. Now this is a good conductor, we say. Now there are so many atoms in this, right? So atoms are available. So these atoms are within the conductor, they are moving, and the electrons are attached to this. You have learned about electronic configuration where outermost electrons are what you call valence electrons. They are easily to remove from the atom. So when one electron is removed from the atom, it is free to move. So it depends on the metal what we use. So you have read different types of metals like sodium, aluminum, silver, etc. In each element there are fixed number of electrons outermost orbit, and these electrons, some of the electrons are very easy to remove because group 1, group 2, sodium, aluminum, all these electrons are easy to remove. So those electrons are gaining energy and coming out and moving within the conductor. Now, a normal conductor, a piece of wire, when you take, a lot of electrons will be there. So these electrons are not moving in a particular direction. So direction is not there. So but it is moving. So we cannot call that movement as electric current. Now, just like you are moving in the field during your interval time, recess time, sometimes when bell is rang, you will just run over and move around, and which direction you also don't know, so you just move around within the field. So sometimes you collide each other, sometimes you move around, and sometimes move more distance, some less distance. So this is the way the electrons are moving within the conductor when it is not connected in the circuit or in an electric circuit, a small fixed conductor, given conductor. Now, suppose you are given a field to that. Suppose your PT sir is giving you a visit, or your class teacher or your headmaster is standing there at the top of the place where you are playing. So then suddenly there will be an arrangement. You may move on in a line and come back to the classes. So this is what happening in an electric wire. So now this will be connected with a cell or a battery connected, more cells or less cells you can connect. So now what happens, the electrons start moving. So electrons start moving from negative terminal to positive terminal. So the positive terminal, negative terminal, the electron will start moving through the conductor. So now you've got a direction which way to move. So it starts moving. Then this kind of movement is what we call electric current. Okay, so electric current, the flow of electrons start moving in this. Now we have the direction for this electric current. So direction of electric current, there are two different directions. One is electronic direction. So direction for the electric current. So one is electronic direction. So electronic direction means the direction in which the electrons are moving. So electrons start from negative terminal and start moving through this. So the electrons will move in this direction. Okay? But there is another direction is what we call conventional direction. So this is the conventional direction. So this direction is nothing but opposite to the flow of electrons, or we can say that it is in the direction of positive charge. Positive charge is not flowing, only electrons are flowing. So we say that opposite to the flow of electrons. So direction against the flow of electrons is what we call conventional direction or flow of electrons. So the direction of current will be always from positive to terminal. This is the convention we follow for a long time from the starting of the invention of current also. So this is direction of current from positive terminal to negative terminal. Okay, so this is not the direction along which the electrons are flowing. Electrons are flowing from negative to positive. So we assume that the current is flowing from positive to negative, even though the electrons are moving from negative to positive. So that is what we always follow, conventional direction of flow of electrons. So electronic direction we will do later in first class only, not now. So this now I think you understood. I hope you understood what is electric current. It is rate of flow of electrons when you are given a cell in the circuit or a potential difference given there, so it starts moving in direction provided by the cell. Now, second term, so understood the current equation is very important. I is equal to Q by T. The measuring unit is ampere and measuring device is ammeter. Right? Now, current electricity is potential difference. Potential difference. So what is potential difference? Now we know that when you are storing water in tanks, when you make it to flow, so you need there should be a two double difference. So your tank will construct only at the top of the building or your house, and the taps will be down there. So you open the tap, you will get the water flowing through that. If the height of your building is more, the flow of water will be also with more force. So this is what is the potential, and so different potential energy you are providing. So the potential difference is also similar to that. Now we are giving a cell, connecting a cell in the circuit. So a negative terminal and positive terminal, that is the potential difference across. So due to that potential difference, the electrons start moving. Otherwise, it will be random motion within the terminal. So when you're giving a potential difference, so how do you define potential difference? Amount of work done. Amount of work done by charge to move from one point to another. So it is nothing but the amount of work done by charge to move from one point to another point in the conductor, within the conductor. So A to B, suppose you are taking 2 points in the conductor A and B. So the amount of work done to move the charge, suppose point A here and point B here. So this is the amount of work done to move the charge, positive charge. You take always the unit positive charge to move from A to B. Now, how do we understand this concept here? So now, before that, you need to understand what is potential. The potential is nothing but the amount of work done to move the charge from infinite to a particular point. So A got a potential, B got a potential in the field. So what is potential at A and potential at B? So potential at A is nothing but the amount of work done to move the charge from infinite to this point. Okay, so we have to move a unit positive charge from infinite position to point A. Similarly, potential at B is the amount of work done to move the charge from infinite to point B. So VA and VB. So VA is a potential at this point, VB is a potential at this point. So different potentials are there. So A is the far distance from the infinite, and this is so there is two different values. So VA and VB are the two amount of work done to move the charge. So potential difference. So VD can be found if you know VA and VB by VA minus VB. Okay, so VA minus VB is what you call potential difference. It is nothing but potential, the work done to move the charge from infinite to point A, and same amount of different amount of work done to move the charge from infinite to B. So you got two different points, and the potential difference comes when there is two fixed points are given to A and B. So potential difference is the amount of work done to move the charge from one point to another point. So from A to B, so there is potential difference. So if A and B are same potential, there is no work is to be done to move the charge from A to B. So there is no potential difference in fact. So potential difference is nothing but the amount of work done to move the charge, a unit positive charge, from one point to another point through a given conductor. Now it is measured with denoted by letter V. So V is equal to work done by the charge, W by Q. So V is equal to W by Q. So potential difference is work done by per charge. So it is measured with the unit volt. So volt is the measuring unit or SI unit. Measuring unit is volt. V is equal to W by Q. So the potential difference is the term which is nothing but work done. It is work done is equal to V into Q, we can say that. So, or potential difference is equal to work done by charge. So, potential also work done by charge. So, potential difference only comes when there are two fixed points given to you. So, two terms you understood, and this potential difference you measure using a device what you call voltmeter. Okay, so voltmeter in current we have learned it is measured by using an ammeter, and voltage is measured by using a voltmeter. So two devices used to measure. So two terms, very very important terms, basic terms in current electricity, current, electric current, and electric potential difference. It is also colloquially called as voltage. Okay, potential difference is also called voltage. But in scientifically we call potential difference, or short form is PD. So potential difference can be. So now when you are making a circuit, let us discuss one electric circuit. So you are learning about electric circuit from class 7 onwards. So there is no problem to understand what is an electric circuit. So in electric circuit, the main components we use, there is a cell, so which is providing potential difference. And of course, there will be a consumer of electricity. We call it as the resistance. And of course, there is a control by using a key or switch there. So this is the basic part. Okay, three components. You are the source of electricity, the consumer of electricity, and of course, the switch or the key. Now we have to measure the voltage and current in the circuit. Suppose you want to measure the current in the circuit, we use, as we discussed earlier, ammeter is a device. And if you want to measure the voltage, we use potential difference. Okay, so potential difference measured by using a voltmeter. So how do we connect a voltmeter to the circuit? How do you connect an ammeter in the circuit? So ammeter and voltmeter also have terminals, okay, where you connect. So there is a positive terminal, there is a negative terminal will be there. Okay, positive and negative terminal will be there. So you have to see and connect accordingly. So you have a positive terminal, negative terminal. So an ammeter will be always connected in the circuit in series. Okay, in series in the circuit, and voltmeter is always connected in parallel to a given resistor only. Okay, so we can connect the voltmeter only across a resistor. The ammeter can be connected anywhere. There is no problem in connecting ammeter. So it is series connection. So suppose you would like to connect ammeter another point. Suppose you want to connect here. So you are always welcome to connect ammeter here. No problem. But you see the connection. The positive terminal should be facing to the positive of the cell, and negative should be facing to the negative of the cell. So you can connect ammeter anywhere in the circuit because it is connected in series. But you cannot shift voltmeter from the circuit other than only across the resistor. We cannot connect a voltmeter here because it is not going to give you any reading there. So you will connect voltmeter only across a resistor. So fixed point for a voltmeter, but ammeter can be connected anywhere because this connection is a series connection. This is parallel across the resistance. So this is what you call your electric circuit, basic electric circuit. Now to find out the resistance in the circuit. So third term of your electricity, current electricity is the resistance. So what is resistance? The English meaning of that, something opposing or resisting. Okay. So resistance is or resistor. Resistance is the property of a conductor or a material by which it opposes the flow of electric current. Something opposes the flow of current. So that is what we call resistance. It is property of the resistor or the conductor. So a resistor is nothing but a conductor. Okay, resistor is a conductor or a material. Resistance is its property. Understand the difference between these two? A resistor is a device or a conductor with got resistance. Resistance is its property by which the resistor opposes the flow of electric current. Okay, resistance is the property by which the resistor opposes the flow of electric current. So R is equal to, or we can is equal to V by I. So it is a ratio. It is found by Ohm, George Simon Ohm. So it is known as Ohm's law. So R is equal to V by I, or it is the ratio of voltage to current. It is what is Ohm's law, the relation between voltage and current. So in any circuit, you got voltage and current and resistance there. So that resistance can be found out by the ratio of voltage to current. R is equal to V by I. So what is this Ohm's law actually? So Ohm's law says that the current passing through a conductor is proportional to the voltage or the potential difference. So current in a circuit. So of course we know that we have seen what one cell is connected, the current flow will be a fixed value. Suppose 2 cells, 3 cells, 4 cells connected. So the energy will be increased. So we can say that the voltage is proportional to the voltage. So voltage, or we can say that depends on the number of cells connected, which is providing the potential difference. So I is proportional to V. So this is what George Simon Ohm found out, that the current in a circuit is proportional to the potential difference between two points in a conductor. So I is proportional to V, and this will be equal to 1 by R into V. So 1 by R is a constant value, or V is equal to I into R. Okay. So this is Ohm's law. We say that I is proportional. So there is one condition is given. The current is proportional to voltage. When it happens, when there is a fixed temperature remains constant. It's very important. So current proportional to potential difference when temperature remains constant. So what temperature can do for current? So we know we have seen that. So the current electrons are moving within the conductor. So temperature increase will gain more energy and it starts moving faster. So your opposition will change. Because why the opposition for the electric current? Because there will be a collision between the two electrons or atoms between or material. There will be a collision. So that collision makes resistance, opposition for the electrons to flow smoothly. So when you increase the temperature, what happens there? So electrons start moving in different directions. They all gain energy. Atoms inside within the element or within the conductor, all of them will get more energy, start moving in different directions. So they will be having frequent collisions. So that collisions will make more and more resistance. So that is why when you make a law when you're making all the conditions should be fixed. So what is the condition fixed? When you make this law, I is equal to 1 by R and V, or I is proportional to V, we have to make sure that the temperature remains constant. So when temperature remains constant, I is equal to proportional to V, or V is equal to V proportional to I, or V is equal to R into Y. So anyway, we can say that. Or we can use different forms by using this, or V is equal to R into I we got, R is equal to V by I we got, or I is equal to V by R. All these are different variations of Ohm's law. R is V. So the basic equation you have to understand, V is equal to I into R. So from this, mathematically, you can change the equation I is equal to V by R or R is equal to V by R. So these three different terms of electricity we have seen. One is electric current, which is measured by using a device called a meter, which is in ampere, and it is the rate of flow of electric current I is equal to Q by T. So all the equations we have already seen equations there. So I is equal to Q by T, okay, and V is equal to W by Q, and R is equal to V by that. So these are the equations. Remember all the equations should be remembered. So I is equal to Q by T. So the current is such a strong thing to flow through a conductor. How do you understand what is current? How much current passing through a conductor? So you have seen that Q by T is current. So current is measured in ampere. So suppose somebody asks you, what is how much is 1 ampere of current? How do we explain that? How do we understand 1 ampere of current? How much is that? So it is a huge value of charge flowing through that. So 1 ampere is nothing but 1 coulomb per 1 second. Means 1 coulomb of charge passing through a conductor in 1 second is what we call 1 ampere. So how do we say how much is 1 coulomb of charge? So we know that total charge given to a material is n number of electrons. So electrons are there. How many number of electrons connected to given to a material? So charge will be given to that. So Q is equal to n into E. So n number of charges, suppose n is equal to Q by E. Suppose Q is 1 coulomb, so 1 by charge of electron is 1.6 into 10 to the power of minus 19 coulomb. So number of charge is for 1 coulomb is 1 by 1.6 into 10 to the power of minus 19. So that is, when you calculate this, 6.25 into 10 to the power of 18. So this number of electrons, so it is a huge number. Normally in your lifetime, 10 lifetime, you may not be able to count this number of electrons. 6.25 to the power of 18 number of electrons, which is flowing in 1 second. So 1 second it flowing from one point to another point. So this is why we say electric current is such a huge thing to understand and to feel, experience. So 6.25 10 to the power of 18 number of electrons flowing through the conductor in 1 second. So that is the wonder here. So that is why electricity is very important. So 1 ampere of current is nothing but when this many electrons passing through the conductor in 1 second. So 1 coulomb per second. And similarly, so voltage also we have seen V is equal to W by Q. When you say 1 volt, so we have seen one small cell is there. So 1.5 volt is the value or EMF of the cell voltage. So W is what we call work done. So unit of work done is 1 joule by charge is 1 coulomb. So potential difference is nothing but 1 joule of work is done when 1 coulomb of charge moving from one point to another point. So then you say that there is 1 volt of potential difference across the points. So distance is not important. The length is not given to you. Only work is done. How much amount of work done per 1 volt. So 1 joule of work is done to move the charge from one point to another point. The charge is 1 coulomb of charge. So how much electron is there? 6.25 to the power of 80 number of electrons. To move, you are using 1 joule of work. The energy consumed by you is that much. Then you say that 1 volt. So we say sometimes the high voltage 2500 voltage or 15,000 voltage. So you are understand how huge the value is. Sometimes you will get affected by high voltage and low voltage. So why it is happening? Because you have to understand what is happening within the conductor. Okay. So 3 very important terms we have learned: the electric current, difference, electric resistance, and we have related both current and voltage using the relation which is R is equal to V by I or Ohm's law. Now resistance is already we have seen what is resistance, how it is coming up. So let us understand how this resistance can be connected in the circuit in a different way. So let us learn more about resistance. Resistance already we have seen that it is the position offered by a conductor. It is measured by unit what we call ohm. Or you write this ohm resistance. Okay, resistance is V by R is equal to V by I using ohms law. We have seen that. Okay, voltage by current. So resistance of a given conductor. So we have to find out now. We have to study about resistance. Suppose you got a conductor given to you. So resistance of a given conductor is proportional to length of the wire. Suppose you got a conductor of a given length. So resistance of a given conductor is proportional to its length. And also resistance is proportional to 1 by A, or we call inversely proportional. Resistance of a given conductor inversely proportional to its area of cross section. Suppose this is your conductor. So this got a length L. Now suppose we increase the length, the resistance will also increase. And you got same thing. The wire got resistance, and if you increase the area of cross section, you make it big area of cross section. So this value and this total value will be different. So how is it changing? Why is it changing? The resistance of a given conductor is proportional to directly proportional length. More length, more is the resistance. How do we understand this? So why it is increasing with the length, right? So if you take this much length, there are certain number of atoms available there, and electrons will start moving within this conductor. So the flow of electrons will be there. So why the resistance? Already I explained to you that why the resistance for the conductor, because while moving, they will collide with atoms and other electrons. The movement will be resisted by other materials. So that is why the resistance. Now it is moving in this direction. It will be interacting with certain number of electrons or atoms. Now increase the length. What happens? There will be more number of atoms and electrons will be available within this area. So electrons moving from one point to another point, this will interact with more number of electrons, more number of atoms. So what happens? The position will increase, or resistance will increase. So we can say that the resistance of a given conductor is proportional, directly proportional to length. Means if length increases, resistance also will increase. So or what you call directly proportional. Same way, suppose you are moving along a street or a market road, for example. So you move 100 meters, you feel some opposition. The same thing, you are moving 1 kilometer through the same busy road, you will find it's very difficult to move. Suppose you are moving along a vehicle or a motorcycle or a cycle, lot of times you have to apply brake, right? If you are traveling 1 kilometer distance, more number of times you have to apply brake. So your resistance will be more. Same thing will be effective here also. When electrons are flowing from one point to another point, the position will be there. And if you are traveling more distance, the length increases, more amount of a position. So that is why we say that resistance is directly proportional to the length of the conductor. It means length increases, resistance increases. Now second part is R is proportional to 1 by A or inversely proportional to area of cross section. What do you mean by inversely proportional? Means the resistance will decrease with increase of area. So area of cross section increasing, one increases, other decreases. That is inversely proportional. Means if area of cross section increases, resistance will decrease. Area of cross section decreases, resistance will increase. So to decrease the area of cross section, to decrease the resistance, what we have to do is increase the area of cross section. Or we can say that resistance of a given conductor is inversely proportional to its area of cross section. Same analogy we can explain for understanding this. Suppose you are moving along a narrow street there. Of course, there will be some amount of opposition resistance will be there when you travel. Same time when you travel through a highway or outer ring road. So you can see that how fast you are going to move. Suppose you are moving along a market road or a narrow road through normal road. So you can attain a certain speed. But same time, a ring road, outer ring road, or a highway, when you're traveling, automatically you increase your speed because the opposition will be less. Means the resistance will be less. So more area of cross section, definitely the resistance of the conductor will be less. Or we can say that resistance of a given conductor is inversely proportional to the area of cross section. Means the area of cross section increases, resistance will decrease. Area of cross section decreases, resistance will increase. One increases, other decreases. So two factors. Okay, so one is resistance proportional to the length, and the other is proportional to 1 by A or inverse. So other factor is resistance depends on, we have seen that resistance depends on temperature. So if temperature is more, resistance will increase. Why I already explained why it is happening, because when more temperature, more frequent collision will be there. So opposition, it is not easy to move. So resistance of a conductor depends on temperature. So more temperature, more is the resistance. So the resistance depending dependency of temperature, we will learn in 12th class, higher classes, more to learn about that. And of course, another one is depends on the nature of the material. So resistance also depends on the nature of the material. Means what kind of material we use, whether it is having a certain number of electrons, or a normal conductor, or a good conductor of electricity. And good conductors also different varieties, like silver is there, copper is there, aluminum is different material got different amount of resistance. So it depends on the nature. So four factors. But this three Ohm's law, we have seen that at constant temperature remains constant. So it is fixed. So we take other two terms. This is of course will be there with the nature. So R is proportional to L by A. So we take these two cases, right? So 1 and 2, R is proportional to L by A, or R is equal to rho L by A. So you remove the proportionality symbol with constant there. So we have to add a constant when you are equal. So R is equal to rho L by A. This rho is what we call resistivity. What do you call that? Resistivity. Or it is also known as specific resistance. Resistivity or specific resistance. So specific resistance or resistivity. So this rho is depends on the material. So it depends on the material or what kind of element we use there. So rho is equal to R A by L. So we can say that the resistivity of a material is different from resistance. Understand? Resistivity is rho R A by L. So it is depends on the area of cross section. Resistance already has depends on area of cross section and length. So resistivity is equal to R K by L. So this is your specific resistance. So this is fixed for a given material. Resistance can be fixed for a given conductor of given length and area of cross section, but resistivity is always fixed for material. If material changes, resistivity will change. Okay, so resistance will change only with a piece of conductor there. Suppose you are taking a copper wire, 10-meter wire, 20-meter wire. So 10-meter wire will have one resistance, 20-meter will have another resistance. But both part or 10-meter, 20-meter will have same resistivity. So resistivity never changes in a material, but resistance can be changed if you cut into different length. So resistance depends on length, but not resistivity. So these terms are very important. So you have learned current, voltage or potential difference, and resistance and resistivity. Okay, so make it very clear so that you can do wonder in class 12, where we are going to study much more about current electricity. So the basic things, if you know very well, the remaining things will be very easy for you. So you can understand electricity if you understand this much very clearly. The basic terms will be used to study further material. Thank you very much.